Today we're going to be factoring trig expressions. Now notice this says completely factor a trig expression. Remember, to completely factor something means sometimes you have to go more than one step of factoring. So let's go ahead and read this example together. It says factor sine squared of theta minus sine of theta cosine of theta. Right off the bat, I'm going to go ahead and tell you that these questions are a whole lot easier than what they look. Okay, basically it's the same as just factoring x and y, and that's why we're going to be using variable substitution to solve these problems. So if you can imagine this as, say, a squared minus ab instead of sine and cosine, you'll realize that this is just very simple in terms of factoring, and if you've taken algebra 2 and you've mastered that class, then you'll have no problem with this lesson. So don't be overwhelmed with all these trig functions. This is going to lead us to step 1. Set each trig function equal to a variable. Now we'll say that after a while you won't have to do this step, you'll just be able to immediately factor this. I just get my students going this way so they can see how easy it is. So I'm going to set sine of theta equal to a. So you're going to see why that's going to end up being a lot cleaner and neater when we go to factor. And I'm going to set cosine of theta equal to b. Now if there were more trig functions, which there's normally not going to be, let's say there was a tangent, you would set that equal to c, so on and so forth. These are just dummy variables that you're going to be replacing these trig functions with. So here's how it works. I'm going to use an arrow and draw. Since sine of theta is equal to a, the sign in this expression right here is going to be replaced with a. So instead of sine squared, it's going to be a squared. The same is going to be true for cosine. See how cosine of theta is equal to b? It's going to be replaced with b. Now notice sine was replaced twice. It's replaced with a down here as well. So this leads us to read the second step together. The second step is to replace each trig function with its variable. So you could have used x and y. I usually use a and b just because that's never going to be inside of the trig function. Sometimes you have sine squared of x, cosine of x, and you don't want to use x, so I usually use a and b. So the sine squared is replaced with a squared since sine is a. Sine is replaced with a here. Of course, the minus carries down, and the cosine is replaced with b. Now, can everybody see how easy this is to factor? A squared minus ab. You're going to pull a GCF out, right, which is going to be a. Now, if you already can tell from this first expression, just pull a sign out, then go ahead and do that, okay? But like I said, generally this helps students realize that it's just a very simple lesson. So now that we have a squared minus ab, we can go ahead and easily factor this. This leads us to step 3, which is to completely factor what we have. Notice it says always pull out a GCF first when possible. That's always the first step for factoring. So guess what? A squared and ab have an a in common. So I'm going to pull an a out of them. We're then left with a minus b inside of the parentheses. And that's all the factoring you can actually do. Once you get to this point right here, you factored it completely. That leads us to step 4, which is to replace the variables by their trig functions. So notice before how we set sine of theta equal to a and cosine of theta equal to b. We're going to now replace the a with sine of theta since that's what it equals to. And we're going to do the same thing for the a inside the parentheses. It's sine of theta. We're going to replace the b with cosine of theta. And that's it. This is now completely factored, and we now have sine of theta times parentheses sine of theta minus cosine of theta. This right here is the factored form of what we started with. And again, you could just notice, hey, I'm just going to pull a sine out and I'm left with sine of theta minus cosine of theta. If you want to go ahead and jump to the shortcut, that's great. I'm just showing you that with variable substitution, it makes it a lot cleaner and a lot simpler looking at first. If you have any other questions about this example, let me know.